Hi, everybody. Thanks for coming to the seminar. So the Evaporative Demand Drought Index is a product that's been under development here between NOAA and Ceres for a number of years, and Mike will be talking all about that. And it's been transitioned operationally to, it's actually experimentally operationally to the Climate Prediction Center. So they will also be presenting, and they'll actually be giving a demo of the new product. So, all right, Mike, I'm going to let you take it away.
Okay, so thanks for coming. Thanks for coming here in the room, and thanks for being online, and thanks to future viewers on YouTube. Check out my channel. Please like and subscribe. I don't have a channel. So, like Andrea said, we've been working on EDDI, the Evaporative Demand Drought Index, for many years. We conceived of it here. We had one transition to an operational setting that didn't quite take. And then we had another one, and that's the one we will be discussing now. So this is just about updates and improvements from the situation where we left it here, and how we're going how we're going to update and improve it to the CPC. First of all, this is a large team that's been working on EDDI over the years in a variety of places: PSL, the CPC, and also the Western Regional Climate Center, the DRI people. And we got a lot of help from the National Weather Service IDP program, the Integrated Dissemination Program team, the Climate Service team, and funding notably from the WPO Joint Technology Transfer Initiative. So this is an image of the sort of CPC team, a bunch of fine-looking folks. So let's start at the bottom line. What is EDDI? EDDI is the Evaporative Demand Drought Index. So it's a new drought monitoring product that is now publicly available as of last September, when the sort of transition stopped, when the transition project completed. It's unique in that it only looks at evaporative demand. There's no other drought index out there that only looks at evaporative demand. It provides a better monitoring of drought because it isolates that single ideal flux. And it's going to enhance the current products at the CPC, the drought monitoring outlook, the outlook products that Highland at CPC will talk about in a bit. There is, excitingly, the public comment period just opened, and I'll share a link to that if you want to make comments. But the idea is it's actually there are a lot of users and applications. You can see them on the bottom. We'll talk about those in a minute. And some users and applications that I had no conception of going into this. So where are we now? After this transition, EDDI is live at the Climate Prediction Center. As you can see here on the left-hand side, left-hand side, you just look at it again. The EDDI front page, the CPC's front page showing EDDI. You can obviously Google EDDI Climate Prediction Center; it'll show up. And on the right-hand side is the really beautiful job that Ada at CPC has put together. The EDDI web pages. They're still in beta, but Ada will take us on a tour of those. And they are modeled very closely on the pages that Kathy here put together for us, built for us a few years ago. Okay, so what am I going to talk about? So real quick background to summarize what EDDI is, how it works, what its uses are. And then we have two, what we've called value-added products. First is one that was asked for by users, these EDDI change maps, and one is a bit more sciencey, about decomposition of evaporative demand. What's the driving demand side of drought? Then I'll talk about the R2O process to the CPC. Not so much the process, more as what it looks like after the process. Then we'll turn it over to the CPC, and they will talk about the products and services they're offering, give us a tour of the CPC website, and then we'll summarize and look forward. And then we'll have that Q&A session afterwards. Okay, so this is the most familiar map of EDDI. This is from a year ago, April 5th, 1 week EDDI, and you can see a bunch of cool colors and warm colors. The warm colors, obviously, but they represent drought categories, drought percentiles. They match the US Drought Monitor percentile breaks as well as their titles, their labels. And EDDI is also, it's wet and dry. It measures anomalies on both sides of the hydroclimatic spectrum. So wetness and dryness categories mirror each other. So for instance, in this map, in around Boise, you can see that evaporative demand is unusually low. Clearly, it must have been a wet period, wetter than normal conditions on the surface and in the atmosphere. Whereas if you look at Alabama and Mississippi, you see EDDI, which is above the 98th percentile dry. So dry conditions are expected only 2% of this for this period. This period is March the 30th to April 5th. That means because it's a 1-week EDDI for April 5th. So you look back 1 week. There are 24 timescales already. This is just one of them. This is the 1 week. That we have 1 to 12 weeks, 1 to 12 months. And this map was issued on April 5th. Sorry, this map is for data on April 5th, but was issued on April 9th. So there's a 4-day latency period. This can be somewhat of a stumbling block for people coming into this. Okay. So to summarize then, this sort of background, what EDDI is, it looks at the anomaly in evaporative demand at a specific point in space, and it expresses it as percentile or categories. So how do we produce it? In a nutshell, we just grab the meteorological inputs from NL-2. They're at 12 kilometers, the gridded, we convert it to daily, and here you can see a couple of maps for temperature and specific humidity, for example. We generate reference evapotranspiration from that. That's a fully physical measure of the evaporative demand of the atmosphere. It's got radiative forcing, vector forcing. Here's a map of sort of the mean annual conditions of evaporative demand. It's greater where it's sunnier, sunnier, drier, windier, or warmer. And then we create, we temporally aggregate and grind it through this Tukey plotting position formula to generate this standard normal distribution. And we take that normal distribution and we map it. So that's how you end up with that map we were looking at earlier. And here are the two papers that they're 10 years old. So we've been playing at this for a few years now. Okay, so it's a multi-scalar drought index, just much like the Standardized Precipitation Index, or SPEI. And here you can see EDDI for a particular date at 9 different timescales. So like I said, we have 24, but here I've only shown 9. And you can see on the top left is the 1 week. That's sort of the weather timescale, all the way through to the annual timescale. And you can see different drying dynamics happen at different timescales, which makes sense. And on the right is the map of the US Drought Monitor, which is for a snapshot at a point in time. For the same date, and you can see there are features in each of these EDDI maps that appear in the US Drought Monitor map. So there is a lot of information that is shared, but also you can parse it out on a multi-scalar basis. Okay. Yes, it's multi-scalar. Yes. So if you want to know what the optimal time scale is, well, that's a function of who you are, as what sector you're in, where you are, what season it is, and what sorts of decisions you're making. So that's not a question that we can really answer for users. They have to become more familiar with it, or we have to come up with a decision matrix for them. Okay, so different uses. We imagined it would be good for agricultural drought, and it is. For farming, for ranching, it reflects soil moisture and ET and grazing health. But it's also shown promise in hydrologic drought, particularly in snowmelt dominating areas. So it reflects snowfall or snowfall anomalies. It's been picked up by the wildfire risk community, and they're very excited about it. Also by the sort of emerging ecological drought ideas, and also by epidemiologists, which was a very interesting thing for me, looking at valley fever, and I can't remember what the name of the disease is, but people are using it to link with that. Okay, so what we have produced at PSL, then, the products we produce at PSL look somewhat, this is kind of an array, look across all the products. We have EDDI maps that have been specifically asked for by specific users, and they may want highways, regions, watersheds, what have you, on their maps. So this is just an array of different maps and regions that we produce. And we also have the raw data files in the raw data or in the categorized data. That has been replicated at CPC and improved upon. Well, our main stakeholders, of course, the U.S. Drought Monitor and the contributing regional authors to the U.S. Drought Monitor, regional contributors to the U.S. Drought Monitor. Okay, so onto the value-added products. This is what the two main products we produced as a result of this latest funding round. The first was requested by users. They wanted to see, well, how much does EDDI change? What are the give me an instantaneous snapshot of the trends in EDDI. How much is it changing? So what you see here is, it's very simple. I don't know if you can read that. That says 2-month EDDI categories for June the 13th, 2017. And then July the 11th, 2017 is on the bottom. So it's a 30-day period. How much did EDDI change, that 2-month EDDI change during that period? Well, here's the difference on the right-hand side. You know, brown colors represent drying, that EDDI is moving from either dry to drier or from wet to dry, but it's moving in the dry direction. And green, which doesn't really show up, shows the opposite. There's not a lot of green here because this is actually the onset of the flash drought in the Northern Great Plains in 2017. So that was requested by the users. What we've produced it at a variety of, remember EDDI is multi-scalar, so we produced this at a variety of time scales and a variety of time intervals. So it goes from very dynamic over on the top left, with 1 week EDDI is changing at 1 week. So it's really what's happening with the weather from week to week. Down to the bottom where you get a long memory, it's a 12-month EDDI and it's changing on a monthly basis. How much is it change? Is a sort of annual picture changing month by month by month. So the idea is we can obviously really rapidly identify wetting and drying trends. Okay, so on to the second one. This is the more science one. This is something we conceived of here rather than have it requested by users. But we asked this, we thought we could answer this question: which variables, and these are the variables here, temperature, downwelling solar radiation, humidity, and wind speed, which variables drive the demand side of drought, by how much and where? So we basically just split out the anomaly in evaporative demand, which is this delta ETO, into 4 contributions. F of T just represents the contribution from an anomaly in temperature. Say in FU2 then is the contribution from the anomaly in wind speed. But more exact, the driving equation is at the bottom, where each of those terms is expanded out. And here's the anomaly in evaporative demand, and here's the term for the contribution from solar radiation. It's a function of the sensitivity of evaporative demand to solar radiation and the anomaly. It's very, very simple sort of linear decomposition of the anomalies. The ugly part hides behind this sort of sensitivity equation there. Not very nice to look at. Normally I like to throw an equation up in the chat, like, oh wow, look how equationy that is, but I decided not to do it this time. So we can decompose every anomaly in evaporative demand. We do it on a daily basis, and we get the daily contributions from each of these. The last term on the right-hand side is this closure error, because there are assumptions inherent in this decomposition, and they're wrapped up into this closure error. And what you want to see is that that closure error is small relative to these other terms, and then you're getting actual information. So what does that look like? Oh, well, before that, let's make this boast. Yes, the world first analytical decomposition of the demand side of the land atmosphere hydrology. And it's got uses obviously in droughts, but also in floods, wildfires, potential uses in forecasting, predictability, and in early warning. And this is something we'll be submitting within the next few weeks, as soon as I can get around to wrapping up the manuscript. But this is what it looks like mapped out. This then is that July 25th, it's the Northern Great Plains flash drought again. And you can see the 6-month EDDI categories on the left-hand side. And on the right-hand side, there's the 4 maps, one for each of those terms. The contributions from temperature is obviously very large. Sorry, down here, oh, you can't see my, the scale is actually just in depths, because the anomaly is expressed in depths, millimeter depths of water. And you can see obviously temperature and wind speed play a huge role in driving this drought at that time scale. Humidity also, but less so. And solar radiation pretty much had no impact. But this is obviously just for this drought, just in this region, just for this season. You can map and slice and dice this data in 1,000 different ways. So let's zoom out to the whole of CONUS for the same date. What was it, July 25th, 2017, and we'll just look at these contributions, how they vary on an increasing timescale. Here we're looking at a 1-week timescale. So these are the contributions to the reference CT anomaly, which is top left. Then the other 4 contributions, and then the closure error. So keep an eye on the closure error as well. What you want to see is that decay away to minimal compared to the information that's in the other maps. So I'm going to increase the timescale here. This is effectively the weather timescale. It's 1 week. Here's a 2-week, and there are significant changes from period to period. Here's a 1 month, and you see solar radiation is already minimal. Closure area is very minimal, except for southeastern Iowa. And as we keep marching through the S to S timescale, here we're seasonal. Here's a 6-month timescale, and you see temperatures blazing across the eastern United States. They're making great contributions to the drought. And here's the annual timescale. And the humidity now you can see actually is turned around, is mediating the drought at that timescale. And the closure error has disappeared. The wind speed and solar radiation contributions have also disappeared practically. So that answers the question of what's driving the demand side of that drought, where and when. Okay, so that is our decomposition. That's our second value-added product that we talked about. This was something we didn't expect at all. This was, what we saw was that EDDI was blazing across the northeastern United States. You can see on that map, the 1-month EDDI, where the US Drought Monitor wasn't showing anything at all, and people were not experiencing drought. So why were we seeing a drought? Why was EDDI showing us a drought when there was no drought at all? This is for in this period of August 22 to March 24, and what the actual Highland and the CPC looked into it, and what she found was this CRDAS, which is an input into in LDAS2, had a precision error in processing snow depths, and was showing a lot of bare ground where there was no actual bare ground, where there was actually snow. And that was transmitting through the NLDAS simulation system and giving us drought. Because we depend on NLDAS, we were showing drought, as was every other drought index that depends on NLDAS. And this was pointed out to us by our users. So having engaged users was really useful in that sense. We corrected this. Highland and NIDIS and our team here, we all sort of petitioned the Environmental Modeling Center to rerun EDDI for that entire period. That is, it's 18 months. And they did it. So it was a big lift, but they did it. So we ran our EDDI and re-estimated it and corrected it. And you can see there's a huge difference between the 2 columns for that particular date. And we were able to do that through a lot of hard work and looking into the data. But had we had that decomposition tool, the attribution tool available, we would have done it immediately. It would have been very, very quick, which sort of shows that it doesn't show, it hints at the diagnostic power of that attribution tool, the decomposition I just talked about. Okay, so trying to wrap up and get over to the CPC here. This shows, this is a spaghetti plot, well, not a spaghetti plot, but it looks like a mess, a rat's nest, if you like. This is what EDDI looked like before we had this R2O process. CPC was where we were getting the drivers. The National Water Center was downloading them and generating EDDI for us. They were piping those files to us. We were slicing, dicing, and creating maps. And then when we were pushing them to users, prone to failure. Very complex process, prone to failure. And the National Water Center said, at one point they said, well, EDDI really isn't in our portfolio looking forward, so you're going to have to do something about it. So we appealed to, well, we applied to the JTTI again, and they were good enough to fund us again. 3 years later, we came up with what looks, well, I hope it looks a lot simpler. Everything from driver processing, EDDI estimation to EDDI dissemination happens at the CPC, and they produce all the end user relevant information, the maps, the data, the attribution, everything. Once again, like I said, that was funded by JTTI. They're an operational center, so thankfully it's a natural home. We, as a lab, IT kept telling me that we should not be doing this EDDI service from our lab, and it was burnt. So this is a much better solution, and it's a natural home. Okay, so what I'm going to do now is turn over to the CPC, and they will talk us through their products and services. So Highland, I hope you're ready out there.
Yeah, thank you, Mike. Can you hear me?
Okay. Stop sharing. Oh, no, I'm going to run it for you. Go ahead.
All right, thanks, Mike. So this is Helen Wang from NOAA Climate Prediction Center, which is also called CPC. And at CPC, I serve as a drought research lead. And for this collaboration between PSL and CPC over the past 3+ years on this operational transition of EDDI that Mike has mentioned, I also serve as the CPC point of contact. So Mike has just provided a really nice summary of this R2O, which is short for Research to Operations. So regarding EDDI from PSL to CPC. So after a number of years of really substantial collaborations and also iterations between the EDDI teams of the two centers, and we're pretty happy to announce today that we now have this upgraded EDDI data and service live at CPC. So next, we're just going to have 3 CPC colleagues talk about the different aspects of the upgraded EDDI. First, I'm just going to provide an overview of the EDDI at CPC with a focus on enhancement that we have made as a result of this collaboration. And after that, our colleague, Yutong Pan at CPC is going to talk about the EDDI data and maps hosted at CPC. And here, Yutong is really our backbone in producing and maintaining these EDDI data and maps. And that will be followed by our CPC webmaster, Ada Uzuma. Ada is going to give you a tour of the CPC EDDI website. And this website is essentially our public-facing platform for providing EDDI for a wide range of end users. So just first, what EDDI does CPC provide? And here, if we just use this original EDDI hosted at PSL as the reference, we could say that the EDDI at CPC just keeps the same functionalities as the original PSL EDDI, but we do have a number of enhancements as listed here. And some of the enhancements actually have been touched on by Mike in the previous slides. So the first enhancement is that the EDDI at CPC currently uses a longer climatological base period for improved estimation. So compared to original PSL EDDI, which just uses 1980 through 2015, and currently the EDDI at CPC just uses a longer period, 1980 through 2021. And really the ending year of this climatological base period depends on when we actually started the production. Here, the regional PSL EDDI just started the production during the year 2016, and the CPC EDDI just started the production during the year 2022. And that's why we had this different climatological base period. But it's thought that at CPC, the use or the inclusion of more anomalies that occurred during recent years can be helpful for better estimating EDDI. And the second enhancement just lies in these new value-added products as requested by end users. The first one is on these EDDI attribution maps, which are currently implemented in real time at CPC. And Mike has already provided a really nice presentation about this underlying methodology and also to showcase the EDDI attribution maps for different timescales. And another value-added product as requested by end user is this National Weather Service web map service for EDDI. And this WMS for EDDI just enables users to have this flexibility to pin, zoom, and focus on specific locations or regions of their interest, which I'm going to provide a little more information later. And just because we now have this NWS web map service for EDDI, this just really enables more precise incorporation of EDDI into the production of CPC subseasonal drought outlooks. And specifically, these subseasonal drought outlooks just include our CPC monthly drought outlook, which is meant for providing drought forecast guidance for the upcoming 1 month. And also this week 2 rapid onset drought outlook, which is essentially the forecast of the flash drought onset at week 2 lead time. So in the past, when CPC drought forecasters are interested in incorporating EDDI information in the production of all these subseasonal forecasts by leveraging EDDI as an important early warning drought indicator, they just typically have had a visual examination of these EDDI maps produced by PSL. But now we have this web map service for EDDI and the corresponding TIFF file. So these just really enable CPC drought forecasters to overlay the EDDI maps of different timescales with numerous other inputs, which also just use a form of maps. So for each specific region, they will be able to just review the numerous input, including EDDI, and apply their expert assessment to forecast the drought conditions at the subseasonal timescales. Next slide. Thanks. Another important enhancement is this CPC EDDI website, which Ada, our CPC webmaster, is going to provide a tour later in this presentation. So here, just really high-level overview. Just want to quickly point out that our CPC EDDI webpage hosts not only the regional EDDI, which just refer to the EDDI category, EDDI changes, EDDI time series, which are currently hosted at the EDDI website at PSL, but also the new value-added EDDI products, including EDDI attribution and also web map service. And also just want to provide a little bit background on our development of CPC EDDI website. During the recent years, CPC has been in the process of migrating our website from our current official website to a new website with Drupal system. And it turned out that there's a development of this CPC EDDI website. This workload is nothing trivial, so we just decided to do this development directly onto the CPC's new website with Drupal system. And just because of that, and this new website is still under development, and that's why you just saw this beta wording in the URL, and which again, our webmaster Ada is going to provide more information when she provides a tour of this webpage. And another enhancement, which is also really important of moving any products or services to an operation center, is that right now EDDI is implemented onto our CPC's operational computing system. And the implication is that the EDDI implementation, EDDI production and delivery would have this 24/7 support. For really rare cases, for example, when we have AC failure in the building and that just led the shutdown of the computer system, then we would have this 24/7 support to come over and look into the issue and fix the issue right away. And if there are any other special occasions, for example, if we have government shutdown for an unknown period of time, and these special occasions would have zero impact on the EDDI production and delivery. So just having this EDDI implemented onto CPC's operation server just really ensures the reliable and stable production and delivery of EDDI product and service to the end users. And lastly, I just want to quickly mention that recently we have gone through this National Weather Service process for implementing EDDI. And for those who are working at NWS, you probably know that this process is referred to the 10-102 process. And currently we're collecting the public comment. And just in case you're not entirely familiar with this process is really a procedure. It's a standardized procedure within the NWS for tracking, reviewing, proving, and also implementing any changes of the products and services at National Weather Service. And going through this process just to ensure any such changes would comply with NWS policy. Next slide, please. So next, I'm just going to provide a little more information about this NWS web map service for EDDI. And first of all, just really a big shout out and thanks to the NWS Integrated Dissemination Program team, because it is this team who actually developed this web map service for EDDI, and of course, in substantial collaboration with CPC EDDI team. And also after the completion of the development, it is also this IDP team who is currently maintaining the NWS web map service for EDDI in near real time. So here we have a QR code. So if you're able to scan the QR code, it's going to take you to this web map service site for EDDI. It just displays the EDDI category and also EDDI category changes for all 24 timescales. But of course, if you actually get to the web page, you can find out you wanted to see some map that you would like to see. You probably need to have multiple clicks to really find out the time scale, to really select the time scale, and also whether you want to see EDDI category or EDDI category changes. So to make the navigation much easier, our webmaster Ada also has developed this special page and added onto our CPC EDDI webpage. And this page just current conditions interactive map, which Ada again is going to show you during the tour. Next slide. And here, just also quickly touch on this NWS process for implementing EDDI. So recently, we're really happy that we have gone through all these approvals, some of just really different layers within the National Weather Service outside of CPC, and some of the approvals just was sequential. And last Thursday, we're pretty happy that we finally had this public information statement, also referred to as PNS, for EDDI published. And what is shown left is a screenshot. And currently, the EDDI hosted at the CPC is open for the public comment. And the public comment period just referred to starting from today, which is March 24th, to the end of September 2026. So this time period just pretty well covered the upcoming warm season, during which the EDDI will be more physically meaningful and useful. And we very much just look forward to all sorts of feedback, including comments, suggestions, and questions. And here we have a QR code and also listed the web address. So all these are just for the National Weather Service survey for EDDI at CPC. So if you have any feedback, please just go to this website and submit your comments and suggestions. So next, I'm just going to pass the control to our CPC colleague, Yitong Pan, to talk about the EDDI data and maps at CPC. Thank you.
Okay, thanks, Helen. These slides gives a brief overview of the EDDI data and maps in for both historical records and near real-time products, all available on the CPC public website. The EDDI categories are offered in both data and map formats, whether you are examining the past conditions or current monitoring. The value-added products EDDI category change and the reference ET decomposition are currently provided for the near real-time maps only. All EDDI category data are available in NetCDF format with one file per day that includes all 24 timescales. And the historical data can also be provided upon request. For update, the near real-time data and maps are refreshed daily at 4 a.m. Universal Time with a 5-day delay to allow time for the input data availability and the processing. So that is a quick overview of the EDDI data and the maps on CPC site. I will pass it over to Ada for a walkthrough of the EDDI webpage.
Okay, I'm going to stop sharing here, Ada, and I guess you have to pick it up.
Ada can come on, they can come up on the cameras if they want.
You can come on the camera. Can hear you, but we don't see your screen.
Well, thanks, Yutan. So good afternoon, everyone. I'm Ada Uzama. I'm the web developer for CPC. And I'm going to just give you a quick overview of the new EDDI products on our website. So currently, there are two main landing pages for EDDI. We have this announcement page on the current CPC website, and it briefly announces that EDDI has been transitioned from PSL to CPC. It shows samples of the three main types of EDDI maps, and then it also links you to the new version on our new beta site. So let me click here and take you there. Okay, so this is the new EDDI homepage hosted within a content management system called Drupal. Basically, what Drupal does is it makes creating, updating, and managing websites easier. And so here within the Drought section of the website, we have a subsection here for EDDI. And in the left sidebar are links for the four major sections of EDDI content: current conditions, map archive, time series, and a resources page. And then on the right sidebar, we have information on how to access the EDDI images and data, along with a link that takes you directly to CPC's FTP site to access that data. And then below it is a link to the interactive version of EDDI's current conditions map, which Hailan mentioned previously, and which I'll go over a little bit later. And so here in the middle, in the main content area, is some introductory text about EDDI. After this first paragraph, you are able to expand or contract the text to read more information on what EDDI is and what it can be used for. And then below that text is a button here that will link you directly to the survey that Hailan mentioned earlier. And then after that are links and thumbnails to the 4 major sections, again, that I mentioned. And then below that is a paragraph of acknowledgements. So let me go through these sections one by one. So first, we have the current conditions, EDDI current conditions. And here in this section, we have displays of the different types of EDDI maps. The first set of images are the most recent category, change, and attribution maps for 1 week. And in the right sidebar here, there are timescale options where you can select between the 24 timescales, 12 for week and 12 for month. And the images will change based on what you select. So if you select, let's say, month and then maybe 2 or 3, and then you click apply, the image updates, as well as the change map and the attribution map below. So each image can be clicked to see a bigger version. And then underneath the category map is a link where you can download a .NET-CDF file containing the data for these maps. And then back at the top here is a link that would take the user directly down to the bottom, where it gives you more information and a description of the maps and their underlying data. And again, you can expand the text and it gives you quick descriptions of each type of map. And then you can contract the text again. And so now I'm going to take you to the interactive version of this page. So this is our interactive map of EDDI current conditions. And this is pulling in WMS layers from the map server that Hailan mentioned earlier. Again, we have timescale options here on the right-hand side that give the user multiple ways to select the different scales and map types to display. You can toggle between category and change maps, and the options will change depending on which one you click and which timescale you select. You can select the number of the scale directly to go to that, or you can go forward or backwards. And then, you can click back and forth between week and month and changes and category maps. And whatever number is selected here will be reflected in the map type that you select. And then below each view, there's a button that you can click to view a larger version of the map, and the link to the image of the map changes dynamically depending on the options you select here. And then there's also another button here that allows you to download a .NET-CDF file of data. So then the next section is the EDDI map archive. And basically this is just an archive that allows the user to go back and retrieve older category maps. There's a date picker here where you can go and click previous dates and then select different timescale options. And then when you click apply, it'll show you the map for that date. And, you know, similar to the current conditions maps, you can click to see a larger version of each map. And again, the button here will automatically or dynamically change to link you to the data file, the netcdf data file for the map that is being displayed. And then after the map archive, we have the EDDI time series page. And starting off, we have introductory text that explains what the time series is. An interactive map here with a regional bounding box and some inputs on the right-hand side with plotting options. So you can either type the values here in the form, or you can drag and change the location of the points, and the numbers will automatically update as you're dragging. And then when you select more options, the averaging period or the ending month, then you click generate data and plot, and it will, hold on, let's see. Okay, and then it'll display a plot of the EDDI values for these options and a table of the values next to it. And then underneath each plot are buttons where you can download the image and a text file of the values, and also a master table of all the values. So if I click here, it'll automatically save the file, and I can view what it looks like. And same thing with the table. I get a text file, and it's a nicely formatted text file of all the values. And then below is another section that has a description of the time series data and the plot. And one thing I want to say about the EDDI time series here in Drupal is a major accomplishment with this CPC version of the EDDI time series is that we were able to convert the older NCL code that calculates EDDI for the web to Python. And NCL, if you're not familiar with it, is NCAR command language, and it was designed for scientific data analysis and visualization. And in 2019, NCAR announced that they were no longer going to be updating the language, and they advised their users to transition to Python. So we were faced with the challenge of converting the NCL code to Python. And if you know anything about Drupal, the content management system, it relies on a programming language called PHP. And it's not an easy feat to get PHP and Python to work nicely together, especially when it comes to a content management system. But we were able to accomplish that and make it work. So that's a major thing. And then finally, we have the resources page. And here on the resources page, we have links to documents about EDDI. There's the EDDI user guide, a PDF document that explains how to read an EDDI map, links to a previous webinar, and also links to various news articles and stories, and as well as a list of references. And so that's basically it for the website. You know, like Highline mentioned earlier, we welcome all feedback. On the landing page, there's a link to our SurveyMonkey survey, and we look forward to hearing what you think about the CPC version of EDDI. Thank you. And I'll hand this back over to Mike.
Great. Thanks so much, Ada and Yutong and Highline. That was quite a prodigious. Oh, I'll let you find the thing. A prodigious amount of work went into producing that web page and the coding behind it. And it's probably the best looking web page I've seen, although I may be a little biased. So we really appreciate the work you Adam was able to put into that. Okay.
Mike,
So-
why don't you start wrapping up?
I'm just going to wrap up right now. Indeed. Okay, so 2 more slides. So just to summarize the outcomes of our project, of our R2O project, we now have a new product type at CPC that measures the thirst of the atmosphere. It's an enhancement of our existing EDDI product that we developed here. We've developed this decomposition of the demand side of land atmosphere hydrology fluxes that is useful for drought, wildfires, wherever you might want to point your hydrology. We upgraded our climatology. We added 6 more years to our reference climatology that is used to estimate EDDI. That's going to improve representation of the far extremes, wet and dry extremes. We created this interactive map, the point and click map that Highland showed us. We created GIS compatible app that's really going to help regional users who inform the US Drought Monitor. It's implemented on an operational system rather than a laboratory system, so it's much more stable and reliable. And it's going to offer this enhanced support to those drought outlook products at the CPC. That will be ongoing and mainly happen at the CPC. The products particularly are the week 2 rapid onset drought that's inside the week 2 hazards outlook, and then the monthly drought outlook. So not only, we've only been talking about CONUS, but there's also a global EDDI that the CPC's international desk operationalized on code we gave them. So they produce it for food security and international, to support their international desk efforts. We also produce it here for the Famine Early Warning Systems Network. And another exciting outcome was this discovery and recovery of this NLDAS error period. That was pretty exciting for us to be involved in that. But looking forward, so obviously we're going to continue EDDI operations. EDDI operations will be focused at the CPC. Research EDDI will happen here, but it won't be piped to the public as we have in the past. We're going to continue to work with the CPC on incorporating it into their drought outlook products. And I didn't know quite how to put this. We are very excited for NLDAS 3, the 3rd generation of NLDAS, I guess, or phase 3. That is really going to revolutionize how we look at drought. It's going to improve the resolution from 12 kilometers for NLDAS 2 to 1 kilometer. It's going to increase the coverage for the entire continent of North America, including Hawaii, the Caribbean, Alaska. Obviously, it's going to be an increased computational burden. I'm not sure how we're going to get around that. The period of record that can underlie for that sort of climatology period is as yet unclear how we're going to work that. It might be shorter. And what's happening at the CPC is this forecasting effort that they've been driving. We haven't talked about that because it's not ready for prime time yet. This new SFS forecast, they'll provide daily meteorological data that can be used to derive EDDI, meaning that we can produce EDDI forecasts up to 12 months lead time. They could also be potentially then integrated into CPC's ongoing development of new probabilistic drought outlooks. I'm reading this because this is not my focus. However, that part of the work will require more funding resources to proceed. And that then is everything we have. Thank you so much for listening, for all our audiences in the room, online, and in the future.